Good morning, children. Last day we have read about one theorem, that was fundamental theorem of arithmetic. That was basically any number can be expressed in only exactly one way as the product of prime numbers if rearrangement of the number has no matter. Next we will go with the help of this. We will try to prove which number the given number is irrational or not. Before that, we'll discuss a little about rational and irrational number. So, in last classes also we have read about rational number is a number which is non-terminating, non-repeating, or only non-terminating number. If a number is given as non-terminating or repeating, whatever that is, how can I understand whether the number is terminating or not? With the help of factorization of denominator. So, in addition of that, suppose you got a number. Suppose I take a number 4 by 75. I understood this is non-terminating, non-repeating. Another number I take 3 by 1250. Suppose a number is given in this form. So I understood by the help of factorization of denominator, this is a 3 by 2 to the power 1 into 5 to the power 4. So this number is having only factor 2 or 5. There is no other factor other than 2 or 5. So this number will be terminating. If I understood this number is terminating, in this situation I have to find at how many digits after decimal it will be terminated, if it is a proper fraction. So for that, what we do, whether it is proper or improper, if it is a fraction, after going in lowest term we go for factorization of denominator. If denominator is having no factor other than 2 or 5, then number will be terminated. And if I got number is terminated, then what I do, I check the power of 2 and 5 both. Whatever is greater, in this question I am getting power of 5 is greater than power of 2, as it is 4 and power of 2 is given 1. So this is greater. Whatever the greater number will be there, that will be the number of digit after decimal to terminate it. So suppose you go for final termination of this number. If you convert this, you will get a number after decimal, number 1, number 2, number 3, number 4. So you have to go for till 4 digits. So now what I have understood, I got, suppose you get a denominator in which 2 to the power is 3 and 5 is to the power 1, then what will be there? This is greater, so this will take 3 digits. Suppose a number you take in which denominator will have in the form of 2 to the power 5 only. No number is given as prime factorization 5, then it will take 5 digits to terminate. If 5 to the power 2, then it will take 2 digits to terminate. So in this situation, I got this number will be terminated after 4 digits. Now some people has told, someone has told, you terminate it without actual division. So in this situation, what I do, I write this number as it is 3 by 2 to the power 1 into 5 to the power 4. And what I do, I multiply denominator and numerator to make power of 2 and 5 equal. We multiply numerator and denominator with the same number so that the power of both should be equal. In this situation, what I see, this is 4 and this is 1. If you multiply this number by 2 to the power 3, you will get 2 to the power 4 into 5 to the power 4. So I have multiplied here 2 to the power 3 in denominator as well as numerator. So now it becomes 3 8 ja 24 by 2 to the power 4 into 5 to the power 4. So if you go for law of exponent, you will get 24 by 2 into 5 to the power 4. So this become 24 by 10 to the power 4. So you get here 0.0024. So this will be my way to terminate a number without actual division. So in this situation, if you are getting a question in MCQ where 1 marks will be given, you have not to go for whole process. What will you do? You go directly, you understand here by which number we multiply both, so that I will get directly this number. So you have to calculate this in your mind. I am getting here 2 is to power 3. So 8 will be multiplied here. So we will get directly here 24. And here it will be 2 into 2 to the power 4 into 5 to the power 4. So you have to understand this become 10 to the power 4. So we put 2 0 here and decimal, so that you will get your answer quickly. So this is my answer directly. So there is no need to give any process for 1 mark question. This is very important. This can come for 1 marks. Next, now we go for some property of irrational number before going further. For rational number, you have learned first, sum of rational number are rational, but sum of rational number are rational, but in case of irrational it is not correct. In case of irrational it is not correct. You have to make these all things in your notebook so that you will revise it properly. Why it will not be correct for irrational? I am writing here not for irrational. Suppose you take 3 plus root 2 and 3 minus root 2. The sum will be only 6. So sum of two irrational number either will be irrational or will be rational. So you have to remember, this is not only valid for rational sum, this is also valid for difference, as well as this is valid for multiplication and division also. For division it is told, division of a rational number by another non-zero rational number will be rational, but in case of irrational number this is not valid again. Now we go further for proving some number which will be rational or irrational with the help of a theory that is called contradiction method. So now we go for contradiction method by proving some number, whether its number is rational or irrational, whatever is given command. So first I take what number. Suppose that number is there, that is a p, and this number is a prime number. This number is a prime number, and you know prime number cannot be a perfect square, because this number has no factor. So this number will not have any this number will not have a perfect square root. Perfect square root number, a square root with natural number, you can say, or whole number. So what I have taken, suppose a number is p, prime number. So what I have taken, I have to prove root p is an irrational number. Is an irrational number. I am putting here p. According to this p, if you are putting here 3, that will be correct. If you are taking 5, then the same method will be there. If you are taking 11, the same method will be there. You understand the process, whatever I am telling, and you have to about to mug up the steps. The same steps will be used each and every time for this type of number. If simple number which is a prime number and a square root of that number is given, to prove whether it is a rational or irrational, then you have to go with this method. So in this situation, what we do, first of all, I have to tell it this is an irrational number. Then what I have taken, suppose it is not a rational number. It is not an irrational number. Then suppose I take this is a rational number. Then what I do, I verify each and every property of rational number with this number. What I take, I will take this number is rational. Then what I do, I will check each and every property of rational number whether it is verifying or not. If it will not be verified, then I will tell I have thought this is rational, that was wrong. That is why this is not a rational number. That is why this will not be a rational number. That is why it will be an irrational number. So this will be my method. So what I do, first step, I take let root p is a rational number. As a by b, where b is not equal to 0 and A and B are co-primes. Co-primes. This means what I have taken? I have taken root P is equal to A by B. In next step what will be there? I will square both sides. So we will get P is equal to A square by B square. What is the meaning of coprime? Meaning of coprime, A and B has no common factor other than 1. So P is equal to A square by B square. Now what will be there? We can write A square is equal to PB square. So this means what happened? This A square is being written in the form of P into B square. That means this A square is divisible by P. So what will I write here? This A square is divisible by P. Therefore we can write A is divisible by P. So in this situation what happened? P will be the factor of A and P will be the factor of A. Therefore we can write P is a factor of A. Now what I take? Let A is equal to PC. What is this P? This is prime number. And C is a multiple of A. Suppose you divide this A by P, you are getting QC as quotient. So you put this in the first place where I have written A square is equal to PB square. Suppose I take this is as first number. So I put this there. So we can write here PC to the whole square is equal to PB square. So this become P square C square is equal to PB square. So this become PC square is equal to B square. Now what I see? This B square is written in the form of product of P and C square. So we can write B square is divisible by P. So what I have got? B will be divisible by P. Therefore we can write P is the factor of B also. Therefore we can write P is a factor of A and B both. Now we write which proved our thinking, assumption, yeah, whatever supposition I have taken wrong. What was wrong? That A and B are co-prime. Therefore, A by B is not. Therefore, root P is not a rational number. Why it is not rational number? Because I have taken earlier this root P is equal to A by B, where A and B are co-prime, but I have got this A and B are not co-prime, so this part is wrong. If this part is wrong, that means this whole supposition is wrong. So we will write here root P is not a rational number. Therefore, root P, if a number is not rational, that means that number will be an irrational number. That's all. So this is very important. And most important, all the sentences, whatever the steps are written, that steps will be remembered, has to be remembered. You have to remember this properly and you have to go properly. the same process, same format will be used, whether it will be root 3, root 5, root 7. Already I have posted one document PDF in which I have proved about root 3 with the same statement. So you will go through with that only, with that also, and you will do rest question. Take care, stay home, stay safe.